All right. YouTube's up too. Nice. So yeah, hey Zach, hey Joseph. Both are doing well. um I saw you're doing some fractal stuff, Zach. Or with like Pascal's triangle, and that evolved into fractals. Remember Night's a challenge? Yeah, I was trying it on Thursday. Oh, I'm not playing music. That's why it's so quiet. Oh my gosh. Uh, what playlist am I going to use? Let's just go back to the old reliable playlist for today. A huge Saturday. It really has fit Fembox, yeah. Um, Zach was going. Last I checked, Penn and Academy of Useless Ideas are both going right now. Territar. Yeah, I'm still thinking about number 9. Academy isn't? Oh, I just saw him on. I wonder if he ended. I had his stream open in the background. Oh, yeah. Tutor Wizard too. Tutor Wizard is really awesome. How many times off of a pen stream? I was just lurking there. I saw he was doing he was proving the limit properties like the sum and product limits. A hint? Yeah, sure. Because I was trying, I was trying it, and I saw. I think it was maybe the power series for 1 over sin x. I saw a stack exchange, so I made a really nifty trick where you thought about the series like a geometric series, but it wasn't quite working out for me here. If Zach is warning me that this one's a challenge, I'm gonna believe him. I think I was trying something else before and I deleted it. Oh yeah, I was trying to do the quotient rule. And that was getting really annoying. Oh really, Storm? That's amazing. One way is like this. Let f of x equal, yep. With some integrals. Oh really? If you integrate it, it has a relationship with, what's it called? Basil's equation? Basil's equation or whatever? Or maybe it's a different integral, but oh, what? So f of, you're rearranging this equation here. Yeah, I swear I've looked at a proof of that before, but I can't remember it either. Fembox. Oh, okay, so this is, you're distributing the f of x into each of these terms and then rearranging each side. I know Spetri. Zach ended up getting first. I was curious who would get it, but on Thursday I started pretty late, so like, oh, I'll start. I was a little bit early today. I started this 4 years ago. Wow, surprised that you remember it. Yeah, as Funbox says. Says use looks, you Nick. You now consider the power series a sub n x to the n. So okay, we let f of x equal some generic power series. Remember, every exercise you did, for some reason you forgot the hypothesis of several of them. Wow. And then I guess we're plugging it into the equation above. Or maybe you keep that one as f of x. Or maybe you don't. You're saying we can use recurrences. Uh, but there's no way, like, we can't combine these sums. They have to stay separate, right? That's that. Example, what is a0? I guess let's go down that road. Okay, so a0, that x is 1. This term is just 1. It's equal to a0. What does the a0s cancel, though? We need these to have, like, different indices or something. No, x term is... What? Then what happens to that x? I... Leibniz... Oh, someone suggested that when I was looking at this on Thursday. It seemed pretty complicated still, though. Uh, I'm very confused. Just to play around with this, what if if I just make these sums all end at 0? I feel like I'm just not getting anything particularly interesting. What if I make them all end at 1? And what's happening here? Uh, so this exists. This is the way? Oh God. Okay. Well, I guess we want to factor an x out. And so x equals 0 isn't particularly interesting. Let's look at the other But yeah, so I don't know, like, I don't know what we're solving for here, I guess. Oh, equating coefficients? Oh, I get it. Okay, I see. A1 minus 1 equals 0. A1 equals 0, right? Aha. Okay, so... Jeez. This is gonna be annoying, because I... I want to go, like, you know, through A5 or something to feel secure that we have a pattern. That means we'd have to do... What do you call, like, a 5 nomial? Basically, like, 5 terms in parentheses times another 5 terms in parentheses. Which we can do, or we can Wolfram Alpha it, maybe. A quintic, like, I guess so. I guess so, yeah, it'll be a quintic because it's a polynomial. Okay, and we can simplify our work because we know A0 and A1, so we can just plug those in off the bat, I guess. If it's just 0, 1, 0, 1, 0, 1, I'm going to be a little annoyed, but... Let's see. It's really inefficient to compute a Taylor series. Yeah, I mean, I did look at the Leibniz thing, but that's also, it seems like that's also going to involve a lot of computations. Like, just when I was briefly like thinking about it. Okay. I'm gonna shove you off in a corner. But just put you there. Put a box around you. So let's make all the summations stop at 5 now. Any more room than that, apparently. I don't like the way that looks. Hey, Rapture. And then on the right side is this bad boy again. I need more room. This is... Being able to drag stuff around is a pretty big advantage compared to, like, whiteboards and chalkboards. Okay, but let's plug in the information we know with A0 and A1. This and on blackboards. Anyone who uses a blackboard is just objectively wrong. I think that's what I've proven here. It just becomes a 1. And that just becomes a 1. I mean, no, not the equals. I swear, Journal++ loves... If I try to click on something to select it, it loves selecting the thing next to it. But you like blackboards? You know, I'm sorry, Finvox, but you know, you're just incorrect. Um, so we can save ourselves a bit of work where I think I'm going to think about it as multiplying this quintic into the other one, because all the terms from this one times everything else cancel out with the right side. Even pencil and paper is old tech. Oh yeah, that's right. You were saying that you're thinking about switching to something digital. So this is so much work. Oh my god. Basically the task is to multiply this times all of these. And on the right side it'll be 0. That's too much work for me. Can I make Wolfram Alpha do this? When in doubt, Wolfram out. A2, I'm going to say is a letter C. X squared plus dx cubed plus e. Oh, it's going to think that's Euler's number if I use e. I'll say f x to the fourth. Do it. Oh, fizz buzz. As soon as I mentioned Wolfram, you're like, yes. No, it's just x plus x squared over 2 plus x cubed over 3 plus factorial 6 plus x to the 4 over 4 factorial is 24 plus x to the 5th over 5 factorial is... Oh wait, and I said I'd take the 1 off. It's just 30 terms. Do it by hand. Exactly. No, Wolfram, you can't just make the problem easier and do that problem. That's... This is why Wolfram can be annoying sometimes. Expand? Okay, thank you. Like, I don't want to do this problem. That's why I'm giving it to you, Wolfram. I don't understand if you don't want to do it. Oh, perfect. Thank you, Fizzbuzz. Oh, this is disgusting, though. Okay, let's get a screenshot of this. Oh, Ben, this is my masterpiece here. So this is part of Zach or Itsu2i Pai's real analysis class that he's doing, and I'm working on getting a Taylor series for this function here, and we're doing it in a really weird way that I haven't seen before. But it does seem possible. So this is terrible. So that x there will cancel with that x there. You never worked on Taylor series before that looks so crazy in a good way? Yeah, this is a particularly difficult Taylor series question. Rapture, if you encounter them in normal calc class, like I wouldn't be afraid you have to do something like this because you shouldn't have to. Taylor series are crazy helpful though. Like, okay, I'll pull it up, but I won't like read it yet. Let's see if we can figure it out for ourselves. And so like especially in like engineering and physics and like things that are more applied, Taylor series give you really simple representations of functions that are just like a little bit too difficult to work with. They also are it makes it easier to compare like the growth of functions as well, up to like different looking functions. Oh yeah, with the yeah, I mean you're right, Storm. I didn't realize it would be this annoying. Uh, but I'm in this deep, or I'm in too deep, and I'm trying to keep my head above water, but instead I'm going under. Okay, so what I gave to Wolfram is C equals A2. I don't know, why am I doing it in green? C is A2. D is A3. I skipped E, so didn't think it was Euler's number. I just wrote E because I was saying E out loud. And G is A5. So I think we actually get that whole thing is equal to 0. And that's... we now have a very simple equation to solve here. This is really just mental math. I say that with sarcasm. So, do we need to worry about any of these things that don't involve any of our constants? Yes, we do. We need to group things by powers. That's the word. So the x squared, we only got one x squared, and it doesn't involve any constants, so I think we're gonna skip that. Do we have any cubics? Yeah, we got a cx cubed. So then from x cubed, any cubics in chat? We get c is a2 plus 1/6 equals 0. That is nice. Okay, so we've taken care. I need to track what I've already accounted for. That's good, and that's good. X to the 4th. We've got A2 over 2. D is A3. Plus 1 over 24 is 0. Bam, bam, bam. And A2 is negative a 6, so minus a 12 plus A3 plus 1 over 24 is 0. A3 is 1 over 24. Yeah. All right. X to the 5th. C over 6, let's just do that mentally. Minus 1 over 36. D shit. D is 1 over 48. F is A4. At least these are all like single variable things. It could have been a lot worse if we had like a matrix. Or if we had like every equation had every unknown. Nutmeg over in the YouTube chat. Do you have any advice and resource materials you can give for multivariate calculus? I sure do. It's time to go into Paul's online notes chill mode, everyone. This is my favorite website for everything calculus. There's very few things it doesn't touch. And so just like look up it in the sidebar and go to Calc 3. And then like this is pretty much everything that you're going to need here. just as a warning, they skip over almost all the theory, and they just go to practical examples of like problems you're going to encounter in your normal calculus class. So as long as, unless you're one of the people who really cares about like learning about the theory and why of things, this website is great. Spark Notes. I mean, yeah, that's actually a really good comparison. It's Spark Notes for math. And I, at least for senior year of high school or grade 12, and probably grade 11 too, I shamelessly Spark Notes and Cliff Notes my way through those classes, and I got really good grades. So, fight me. Should make a Zaxxnos website. That would be awesome. I might be misremembering, but I feel like at one point you were saying that you wanted to like write a book on analysis. That's true. You cannot Spark Notes your way through grad school. I have no plans on trying that personally. I'm Wolfram Alphaing this fraction math, by the way. Which Wolfram Alpha, it's like using Wolfram Alpha to get through your math classes like using ChatGPT to get through English class, I think. Except Wolfram Alpha actually works. Well, no, ChatGPT would be good at writing essays, I'm sure. 1/720. I'm gonna make it negative. Wait, do I make it? Yeah, it's positive 1/720 on the left side. So A4 is negative 1/720. What a terrible number. Spark Notes, it's, yeah, Zach gave an example there. It's a website that basically just gives you the bullet point summary of books that are frequently used in English, like literature classes. So, like, I remember in my English class, we were forced to read many books, but I remember the one we spent the most time on was called Heart of Darkness. I feel like I should have read it because it's a genuinely interesting book, but wait, where's the notes? Wait, they make you buy it now? Oh, not cool. Wait. Okay, no, you can still get it. Yeah, it's pretty brutal. It's about oh gosh, the Dutch king. I think the phrase is like it's the personal property of like the Dutch king and the like was the Congo, and there's a whole bunch of just terrible stuff happening there, like cutting off people's hands and stuff. If they didn't like, I think they were producing rubber there, and if it didn't produce enough, my memory of it is really spotty, but oh, Sparkles actually does do math? Wow. All right, see you, Storm. Thank you for the well wishes. I should look into the Leibniz way. Huh. That's kind of cool that they do math also. Yeah, it just it gives you like a quick summary of long books that you don't most people don't want to read. So like Shakespeare books especially, or Shakespeare's plays, I should say, are probably like the most common things. They're so hard to read. Oh, it does it through like the AP Calc lens? Okay. Are those all the names that country has had? Okay, I'm just going on a tangent. Congo. Uh, I'm sure the Wikipedia page would have this, right? Like, what are all the names this country has had? Which is made for you? Reading in the content area? What is that about? Kinshasa? In chronological order: Congo Free State, Belgian Congo, Republic of Congo Leopoldville, that was the name of the king, Leopold, Democratic Republic of Congo, and the Republic of Zaire. Before returning to its current name, Democratic Republic of the Congo. Well, now I wonder what region of the world has had the most names. That'd be I should ask that to Shane McInnes, who is an awesome like history streamer in sociology. Shane McInnes, if anyone's curious. Um, okay. Uh, how to read textbooks. I griped my way through about a month of it before realizing that math could use this overhaul. Really? It's a book about reading. Reading in the content area. Look at this. Oh, maybe I need to add book. That's not it. I mean, okay, let me. Amazon likes to like just put up your city on the screen when you look at it, so I'm gonna hide it when I look. I've leaked it about a million times, so I don't really care that much. But actually, I don't even see it on the screen right now. Oh no, I do see it. Never mind. Because I probably just shouldn't care because I've already leaked it in half my streams. But hmm, all right. Two class series of my community college. We didn't use that book, but something like it. Okay, fair enough. Um, what's the pattern in these numbers already? We go from 6 to 24 to 720. What are the factors of 720? 720 feels like a familiar number. Like I feel like I've had to deal with 720 before. I can see the Roman numerals. Maybe this is a job for OEIS. 6, 24, 720. 6 factorial? Oh, Territar. Okay. That must be where I've seen it before. So this is 3 factorial, 4 factorial, 6 factorial? That's annoying. We just skipped over 5 factorial. First class I was said about needing tickets. Second class, that guy and I hit it off immediately. We had one of the guy who taught math and was also really upset about needing a ticket. We almost converted him by the end. Okay, I guess let's get another Or let's get some more terms. Or we only have the budget to get one more term, A5. So let's hope that that's enough. X to the 6 tells us A2 is negative 1 over 6 times 24. Oh, that's so annoying. That's definitely a number. 6 times 24. 144? Oh, I should have figured that out. It's 12 squared. Uh, 1 over 144. All right, see you, Obi. Thanks for hanging out. D is A3. 24 times 6 again, funny enough. So plus 1 over 144. That X to the 6, F. A4 minus 720 times 2. 1440? 1440p? Oh, wait, yeah, 720, that's like 720p. Huh. Oh, we get a double negative? I'm doing this wrong. I don't think there's an easy pattern here. It goes negative, positive, negative, negative? Hmm. Now, at this point, I would want more terms, but you couldn't pay me to get more terms right now. I'm debating if I can salvage this with what I have, or if I should try to figure out the way that Storm wants to do it. Or I can look at the thread that Zach linked. I'll probably look at the thread that Zach linked. Yeah, let's do that. Spoiler alert. I did it wrong. Uh, A1 is evidently not 0? So I've been wrong for a long time. What's happening in this one? Cancel up the top? I guess in this fraction you're canceling x. I don't know why there's not a 1 over x there, though. Because... Oh. Okay, I see why. Okay, so this is the way that I was trying initially, right? But I didn't know how do you deal with this kind of double summation that you're getting. Oh, you expand it just enough to know, to be certain what the x term is, I guess. And then be certain what the x squared term is. Hmm. Okay. Let's see if we can go back and make this way work. Like, apparently I've just been wrong from the get-go. Like, I got the wrong answer for A1, so I think I was already, like, done for. Focus. Thank you for the follow. Okay. This is a teardown job here. Were you doing a Taylor series expansion for 1 over 1 plus x earlier? Yeah, Teratar. I think I said that's just -1 to the n, x to the n. Yeah, it's right here. Okay. You can get deleted. Go to the shadow realm. So A1 is allegedly -1/2. Can I salvage this work? Hey, famished. What did I do wrong here? What did they do that's different? Oh, they worked with it from this form. Oh my god. Okay, that light change got me there. It's funny. I started with the lights on blue today, and then someone changed it. I forget who. Um. Yeah, I maybe let's actually. I don't know why. Can I figure out why this is wrong? I sure can't. So let's get rid of it. Okay. From this stage, we'll do this. As a stack exchange thread did it. Bernoulli? Does Bernoulli have something to do with this? They divided through by x, but that's gonna mess with the... Oh, they turn it forward. He does? Okay. For the product of two infinite series. Oh, 1 over 1 plus... Wait, are you saying that 1 over 1 plus x has something to do with the product of two infinite series? Territory? Oh, that's what Bernoulli. Sorry, you're looking at the chat up there. I'm the technique that we're gonna use, I don't think it's gonna use some identity there. Generating function for Bernoulli number. Really? I've seen these before. Usually, when I do see them, I'm like, oh, okay, this is beyond me. This is beyond me. Talking about the Riemann zeta function here. Hyperbolic cotangent? Disgusting. But okay, I do see the x over e to the x minus 1 thing. Okay, there's a step in the sex change thread that I don't quite understand, which is what happens when we divide each side by x here? What? Oh, I don't know how math works. That's the issue. This, I was canceling the x with both of these series, but that's just not how math works. You cancel it just with that series, and then you can just do some index shenanigans. I don't know how math works. Someone clip that. Yeah, why do you think I like applied math? Um, I don't want to see him literally die on stream. No, I mean, yeah, Zach gave a second change thread that basically spells it out. It doesn't seem that bad. Um, okay, so this is n equals 1. It starts from x to the 0. So that becomes just x to the n. That starts from 1, so that's n plus 1. Why can't I draw a straight line? Equals 1. Okay. So let me see what the thread says now. By expanding and equating coefficients. Yeah. Keep on saying you still give no apologies. I mean, this way seems pretty achievable. You hear Bilbo Baggins died of a Viagra overdose? Apparently old hobbits died hard. God damn it. I really didn't know where that was going. Oh my god. That's a good one, Jim. Infinite system equations to solve. Well, you actually can. Or, well, someone can. It remains to be seen if I can. But the one ring where he shouldn't have. Oh no. Ugh. I'm probably not going to go out this many terms, but just so we have them. Okay, so we only get one constant term, right? Which is from a1 times 1, or a0 times 1. So a0 just equals 1. And now we go, how many ways can we get x's here? We can do a0 times 1 over 2 factorial x. So a half a0. We can do a1x times 1. So we get that. And then we know a1 is a half. Aren't I supposed to be getting minus a half? Oh, no. Common issue. I don't know how math works. That's a recurring pattern here. Hey, speaking of patterns. Yeah, thank you, Mega. Okay, then we look for x squareds. We can do, hey, Dr. Ill, an a0 times that, 1 over 6, and I'm just going to know that a0 is equal to 1. We can get an x squared from a1x times 1 half x. Wait, so it's minus a half times a half is minus a quarter? And we get an x squared from a2x squared times 1. Ooh, light show. Oh wait, you know what? Can this thing actually do a light show? I feel like it might be able to. I might need to look into how to set that up. I know it can, like, it has like a microphone and it could listen to music you're playing out loud. But I'm not going to play music through speakers. Well, let me see. It might have some, I think it has some pre-programmed things, I feel like. Universe. What's universal about this? Are they transitioning at all? I wonder if it's really gradual. I don't know. Starry sky. I think these are just preset colors, I feel like. Downpour. How is this downpour? I was hoping it'd be like, it would like transition. Valentine's Day? That was just here. Don't let Elon find out your lights are transitioning. Oh, jeez. Display flowing lighting effect. Wait, what about this is flowing? You might need to leave it turned on for a while. Like maybe they're very gradually changing. I was hoping for like laser lights. Uh, Harmony Lab. Waterfall? Oh, it's playing music through my or like water. No, okay, this is stupid, dude. Maybe I'll look more into that another time. Um, they were on blue, but before. Yes. So we weren't like giving them the problem, but these are apparently related to Bernoulli numbers. We're finding a Taylor series for this function here. Yeah, generating function. Oh, jeez. I didn't hear about that, Mega. Yeah, like I have no interest in getting any sort of political on Twitch, but I'll say generally the stuff that's happening is you know, at least it stresses me out when I just like read about things that people are saying, and it makes me want to like I don't, it makes me wonder like what good that I can do as like at least one individual, but I'm just like I'm not sure. It's locking on Bernoulli numbers, you know, some bits and pieces, but no connections. Yeah, I bet someone around might be able to point you at least in the direction of something to like look up more. Uh, I've hardly like seen them or worked with them. Yeah, no, it'd be cool to do some kind of like charity stream of some kind. Um, I just I wonder how effective they are for like small streamers. 6. Can you be the charity? I think it's just called being a streamer. I mean, you say that jokingly, Mega, but like Gold like actually does like you know his stream is all in the name of the charity that he has. F of X approaches F of A as X approaches A. For a continuous function, sure. How does this fraction math work? We get 1/12. Yeah, it's 1/12. Let's get what are you supposed to calculate? Okay, so um this function is difficult to find a power series for by conventional means. Or and what I mean by that is like this formula here, it gets really complicated really quick. Apparently, it seems like you can make it work if you use something called Leibniz's rule. I think it's called that at least. Um, I didn't try it for myself, but apparently it works. Um, Another thing you could try is looking at um, the power series for the reciprocal, e to the x minus 1 over x, which was actually the previous problem, and I did that. But it doesn't seem to be helpful. Um, and so the way that I was advised to try, that I've never seen before for a problem like this, is just to let f of x be a generic power series and plug it in to the original equation or rearrange it to get the e to the x minus 1 to the other side. And so you know f of x is some generic power series. You know e to the x minus 1 has a pretty easy to get power series, and x is just x. So you can divide the x over to the other side, and the test basically becomes to figure out what these a sub n's are, which you can do by equating coefficients. So that's what I'm working on right now. Interesting pronunciation of Leibniz. I feel like I was taught to pronounce it Leibniz, but everyone else pronounces it Leibniz. Um, I don't know which one is right. I there are so many things that I was taught to pronounce a certain way during my degree that people on the internet just seem to pronounce a completely different way. So I don't know. Can more the Leibniz root? Oh, is there potentially a T in there? It's the latter? Okay. I guess let's go for another term. I was just thinking about that, Mega. Why is one Euler and the other one Euclid? I know that. I mean, it's the answer is that they're different. They're from different countries and different eras. But like, it's still annoying that it's Euler. It's not Euler and Euclid or Euler and Euclid. It's Euler and Euclid. Yeah, yeah, exactly, Mega. But it's so annoying, right? Euclid. Apparently, the B is pronounced more like a P in German. Huh. No clue. Spelling of Irish names. Oh, I mean, what comes to mind for me is like the name of British cities. like they're spelled super weird and pronounced only vaguely like how they're spelled like the sauce Worcester. Like you would just say like Worcester or something, but it's like it's spelled like Worsh. There's a syllable in here that I'm forgetting. Shire. Worcester. It's something like that. I don't know. But it's just like Worcestershires. I'm saying it too much, so I'm getting it now. But Leibniz? Leibniz? Huh. Has someone pronounced this on YouTube? Pronounce Leibniz. Why is there music? You don't need to introduce... Leibniz? It... Okay, he pronounced it two different ways in that. One, the B does sound a little more like a P. The second one, it just sounds like a B. I don't know. You're lying. I am more confused than before. Wash your sister sauce? I mean, the real answer is just don't go on TikTok. Okay, I think I need another term here. So this was the constants, this was the x's, this is the x squared. So what's the x cubes? We can do a0 times that term. 4 factorial is 24. We can do this times that. A1 is negative a half. So minus 1/12. We can do this times this. A 12th times 2, or 1/2, it's 1/24. That's zeroing out. That's concerning. Plus a3 equals 0? That can't be right. You can do a0 times 1/4 factorial, which is 1/24. You can do minus a half times 1/6, which is minus 1/12. We can do 1/12 times 1/2. Third Bernoulli number is 0? Bruh. So wait, then how am I supposed to actually get this? Can solve these equations inductively to obtain the values for CK. Can I, though? Numbers low-key haunt me. Why is that? Oh, I've heard of Sterling numbers. I can't remember or like where they come up. What is that finished? Oh, yeah, I'm sorry. I remember you put that series down, and then I just got too busy to look at it that day. So, like, I don't know how I'm supposed to get this naturally, but like, the answer is just going to be this. Like, I guess that part right there. I assume there was going to be some kind of recurrence that will be easier to solve here. Hey, Rob. Oh, well, good luck on your exam tomorrow. Be your last time. I am thinking that I'm just gonna give up on this problem, at least for now. Might be better to try storm strategy, but I might want a little break from analysis right now anyway. You have another series problem, but it's that I know the answer, not the proof. So you're trying to prove that the answer is right? Oh shoot, I'm not even showing my screen. Or this thing. If you want to talk about it, feel free. There's nothing happening right now. Hey Jasu. Okay. Sorry about that. I was just reading something on my Discord. So I mean, syntax. If you have something you want to talk about, let me know. If not, I'm just gonna probably find a physics problem to work on. It's been a minute since I've done that. Oh, you do have. Okay. Why do I just have a blank page here? Well, that's convenient because I want a blank page here anyway. Hey, Ishan. Sterling numbers. Yeah, apparently syntax was looking at them. If I'm going to his problem, can I solve the helium atom? What does that mean to solve the helium atom? Oh, I did, Ishan? Well, I'm glad to hear that it helped you. Good luck with the rest of your math journey. Oh, that's true, Cytos. You did do that. I forgot about that. It seemed like I could probably do it, even. Um, but let's talk about this series first, and then we can take a look. We can only do it for hydrogen, so I'm curious. Schrodinger equation. Oh, okay. Well, I sure can't do that problem. um, that looks a whole lot like the formula for the sum of squares, doesn't it? Or it's not, it's somewhere between the sum of squares and the Gaussian sum, right? Because it has a 2n plus 1 like the sum of squares does. But it's missing the n plus 1? Yeah. So it feels like there should be some means, if that is true, there should be some way of expressing this as some sort of sum of integers, right? And of course my journal plus plus is getting stretched out because it hates me. Okay, well, I think I need to see some example values of this sum. So if k equals 1, wait. Ooh, n is fixed. Wait. Is this n supposed to be in the denominator, or is that k? N? Okay. Okay, you have a Desmos for it, thank you. Minesweeper? Let's go do that quick before I forget. No guessing. Um... 35 or 36 seconds? Nice. That's one of my better times on this site. I accidentally misclick all the time, Mega, to be honest. But if you want to, if you gotta go fast, then in my mind, you shouldn't use flags. So, oh wait, the red is the sum. Is, oh, I see what you're saying. That's why you think these two things are equal. So the first one is 0, and then, oh, wait, oh, these aren't flat lines. What? Oh wait, no, we only care about integer values. Okay, okay, never mind. Then it jumps up to 3. And then 10? It's kind of like approximating the integral of tan squared of x from 0 to pi over 2. N is the floor of x. Oh, is that, I don't know what's happening. Which one do I, if I want 1, I need to do this by hand because I'm confused if I want the lower one or the upper one. Hey, Cook. I think I agree with Jasu. I think there's no shortage of physics questions that we can't answer. Well, hey, or maybe answer, or I guess, solve. You never said solve it correctly, right? Yeah, it does. I'm trying to be a smartass. Oh wait, why was I thinking these aren't? Dude, I don't know how graphs work either. I was looking at the x values increasing, like, oh my god, it's not a straight line or a flat line. Denoli Dice, thank you for the follow. Oh wait, so we take the upper, like for one, we take the value on the left. For n equals 1, you get 3. N equals 2, you get 10. 21. 36. Those numbers feel familiar. That feels very nearly Fibonacci. Yeah, I mean, if you want to do induction, you got to figure out a pattern, I guess. A man goes to a job interview. The interviewer asks if he has any special skills. I can do arithmetic incredibly fast. Oh, is that so? What's 426 times 831? It's 154.32. That's incorrect, but it was very fast. I love that. Oh yeah, you're right. Syntax. I'm dumb. N to n plus one. Papadoria. The problem is to, I guess, find a closed form for the sum of this series here. And we suspect that it's n times 2n plus 1 based on the Desmos that syntax error made in the Twitch chat. Induction, I guess, is what you want. This should be a known result. OEIS is probably where you want to go. Second time we've used OAS this stream. 3, 10, 21, 36. 3, 10, 21, 36. Second hexagonal numbers. That's one match. Thinking of complex definition of tangent squared. Maybe. What a... Triangle of triangular numbers read by rows constructed like this. Given a sequence t, start row 0 with t of 0. Is this inverted Pascal's triangle? What the hell is this? All right, someone make Zach find out the probability of getting an odd number from this pyramid. um... What are the individual terms here? Like that's what I want to see. Wait, I mean, it's not the right numbers for Pascal, but it does involve triangular numbers in some way. I mean, it depends on n. That's what trips me up about this series. I guess we need to do it like for n equals 1. Like do like a table of it. Like I want to know the individual terms. But then what is that's so annoying though. Oh yeah, it's the song Femvox. No, it's the other song. My bad. Where is the song in the queue? I don't see it anywhere in queue right now. Oh, I see it. It. Well, let's bump it up. That's gonna take way too long. I'm putting the song right after this. That girl Destiny, do you by any chance help with ER diagrams? What is an ER diagram? Yeah, I'm wondering about trig identities. Like, syntax. I mean, entity relation diagram. Huh. I've never done one before. Maybe I can figure it out. Elden Ring diagram? Oh my god. I'd much rather do a Dark Souls diagram. Hey, Central. Uh, if you want, you can try asking your question, and me or someone in chat might be able to help you out. It was easier to put a screenshot. Oh, for databases? Okay. Yeah, I've done a database class before. It's been a while. And Jed is probably fresher on it than I am. But if you want, just type what you want to do out there in chat, or if it's easier to put a screenshot, I have a Discord where you can do that too. You know, if you shape Central, those will come in handy. But yeah, next, I guess like normally when you have a series involving a trig function, I want to look at the individual terms, and it'll usually like you usually just find some other pattern that represents it better. This one is kind of annoying though. Would Wolfram Alpha get this for us? Like just like a table of values? Because like I just want to re-express that series as something completely different that's ideally simpler. Get example values, please. Really, Wolfram? You don't want to do it? I don't want to do it. That's why I'm asking you. Uh... Yeah, I guess if you try to do an induction just with a tangent squared, I feel like you're gonna fairly quickly get stuck. Um, hmm. And what's within the Discord Destiny, just give me heads up so I know to check it. Oh, here's the exact formula. Ah, April 7th, but like where? It's saying invite is invalid. I hate it when Discord does that. Uh, oh, it's so weird because I can see that someone named Destiny just joined the Discord. Um, how can I invite people? Let me try this link. Really? Your hello wave is much cooler? Yeah. I am flabbergasted. Uh, this I'm trying to make a Discord invite link, and when I hit the button to copy the link, this is what gets pasted. Like I hit the copy button, and it copied that text anyway. Let me. Well, one second. I'm sorry. Okay, maybe try that link. I had to turn off streamer mode for that, which I have no clue why Discord would be built like that. Papadoria is saying that tangent squared. No, not really, Jed. We could get it backwards from looking at the sums and subtracting things off, I guess. Well, what am I really after here? I don't know what I'm after. Uh, that is something, maybe. Like maybe you'd be able to deal with the plus ones in the cos, like using the cosine sum identity. I'm skipping over the base case because who likes base cases? Not me. The link didn't copyright? No, it's fine. Wolfram links are... Nah, I got it. When that happens, you have to highlight it and copy it. N equals 1. Okay. Oh, shit. Is this going to be this? Oh, shoot. What was I trying to do? I'm really confused with the K's and the N's, to be honest. Yeah, I guess the issue is that the terms depend on N. So maybe you just can't really look at the terms in a clean way. Like the thing that makes this weird is that N is included inside the summation. Like I'd love to figure out what Ignacio Larosa Cañestro did in 2001. Can we Google that name and date? I'm looking at I don't I didn't know if like what would show up, so I'm hiding the screen right now, but um I'm not really finding it. Oh, is that what you get if you just subtract off the things before? Um, yeah, and I don't know why I wasn't just doing that before. Um, tan squared dot dot dot. I don't feel like rewriting the entire thing. Hey, Yanis. So that's the type of thing that I wanted to express this as. Because that difference is 7. That difference is 11. That difference is 15, as you say. So it made you an entirely new account, Destiny? Okay, that's super weird. I don't know why it would do that, but yeah, as long as it lets you post the problem, I guess. Contour integration? I never used that myself, or I don't know how it works. Um, I think the point of this though is that you could make the claim that the sum from k equals 1 to n of tan squared k pi over 2n plus 1 is equal to the sum from k equals 1 to n of 4k plus 3? Just like math discussion is fine, I guess. Towards the bottom of the list there. Just 2k, Judd? Aren't we adding 4 each time, though? Oh, sorry. Ooh, 1 plus 2 plus 3 plus 4, 1 plus 2 plus 3 plus 4 plus 5 plus 6. I'm really I'm not so from k equals 1 to 2n of k. Oh, huh. Because this is the Gaussian sum now. It's like the regular Gaussian sum. I think is n plus 1 over 2. So if you plug 2n into that, you get the exact thing that we started with. That's funny. I like that. Yeah, Gauss's sum. I like this equality here is still sketchy. But that's a neat find of what the right side is also. And it's funny, there's a relationship between wait, I'm gonna say something stupid, aren't I? Thank you for the follow, Destiny. No, this is a problem from syntax error. Trying to find a closed form for this summation here. Syntax error via Desmos has found this is probably the answer. And we were trying to prove that. 25. I might take a little break to look at Destiny's problem, though. Oh, yeah, discrete math is not my best. It's not my best thing. Oh, you have to do it in Visio? I didn't use Visio for database diagrams. I've used it for, like, flowcharts, though. Ugh. God. Databases are... The concepts are really fun, but making a trillion UML diagrams was the absolute worst. I think we can come back to this, but I think I would like to take a look at Destiny's problem here. You're not using Visio? Oh, okay. Sorry, syntax. I feel like that's going to take a lot more digging to try and find an answer to your problem. Um, no, it's okay. I'm not particularly close to solving this problem, I don't think. Um, and so, I mean, we'll see if this one, like, how long this one takes or where you, like, where you're at. So I see Jed asked, I haven't read the problem yet, but, like, where are you stuck here? Or, like, what are you asking me about specifically? Customer attends a concert. Customer has those columns. A credit limit? Okay. Primary key of customer's customer number. Concert consists of concert ID, name, start date, end date, city date, state, budget. Producer produces a concert. Seems reasonable. So presumably we're going to need to have some foreign keys here too. Like, I guess we could even just sketch this out by hand. So we have customers, concerts, and producers are the three tables we would have. It's been a minute since I've done these. Where to even start? Because the first one of these I did, I completely bombed. Okay. Um, I don't know how much it varies by the class. I do remember there's some pretty particular formatting though. That I am definitely going to be rusty on. But from what I remember, okay, let's actually look at that, Jed. Yeah, okay, this is what I was imagining. Something like this. He didn't dive deep into this. Oh, well, okay. Hopefully he's not going to be that picky on the exact symbols and formatting of things. Um, I wish they. I wish they'd be more specific about what each of these symbols means, but like the thing that this diagram is conveying is that you have a table for customers, and customers have ID. In this example, they have IDs, names, emails, and addresses. Um, Customers have the primary key as their ID, and I assume this plus means there's one customer on this side can make many orders over in this table. And so each order has a customer ID associated with it. And you might have many different rows inside this order table with the same customer ID because the same customer's ordering many things. Okay. And then there's like a many to many. Really? Why is this one going to the header? A product. Maybe because there isn't a specific row or that. I don't know. That's sort of a weird case. Probably won't have that. Um, one to many and then many to many. Yeah. Many orders have many products. Oh, is that why it's at the top? I'm just wondering why it's at the header and not like we're a foreign key. Um, Out of context, it sounds so stupid. Yeah. Is there in formal set notation? Is there a way to denote that a set is strictly finite in cardinality? Uh, I guess you could say that the cardinality is a natural number n or something. I assume, or the cardinality of A is less than infinity. Okay, that might be your answer then, Papadoria. So I guess let's go through this situation that's here. It's interesting to like that they actually specifically put that on problems now. I haven't been a student since ChatGPT has been a thing. Anyway, so let's start by making the product diagram for customers. So customer has I guess we need to invent names or like an actual like variable name. That's like one word. I guess we'll follow the conventions in the link that Jed put and say like customer, the capital C underscore ID. And we'll say that's a primary key, PK. This might be better typed. It's actually, I think let's maybe type this so it's a little more legible. First name. Yeah, I took a similar class, Zach. SQL is kind of it can be a fun puzzle. It can also be a really annoying puzzle to write a SQL statement. Okay, so we got customers. We have concerts. You informed you have to use Visio. Oh god. Okay. Name, start date, end date, city, state, budget. I think we're gonna have to add something onto here, but let's just for now we're just focusing on the exact stuff that the what problem is saying. Producers, PK, ugh, no. Producer number. Name, revenue. Um, uh, Excel is the superior DB. Oh no. That's like me saying infinity over infinity is one when you're doing the analysis class. He's making a table, he's sorting it twice. Select star from contacts here, behavior equals nice. Or where behavior equals nice. SQL clauses coming to town. Oh my god. That's funny, Zach. As someone who has used Excel as a database in the office job that I used to have, it is not a good database software. I mean, it's fine for small purposes. If you have a lot of data, though, it gets pretty bad pretty quick. Okay. So in a vacuum, these are all the columns that each of these tables would have. But there's some relationships between these tables that we have to express. So a customer can attend 0 or more concerts. Let's deal with that one. I think how we're going to do that is put a foreign key in concert for customer ID. And a customer can attend no? Oh, you need an intermediary table, don't you, Jed? You need to put something in between here? Is that it? Yeah, I think that's it. The concert belongs to one and only one customer. The lower bound for the series, but it's really bad? Okay. So you could do that with producer, okay. So we will do that with producer then, if we deal with the last sentence then. But then if we... And then you would make... I don't know what the symbol is for just one. I assume it's that little like plus thing, but like you would have 1-to-1 there because a concert is produced by one and only one producer. Well, like no. One producer can make many. Yeah, you're right, Jed. I'm screwing this up. One producer makes many concerts. If you just want to hop in voice, Jed, please let me know. You're way fresher in this than I am. It might be this. Hey.
Only if you need me or want me.
Sorry, I mean, you type no in all caps twice, and I'm like, all right, just give me the answer then.
Well, just no. What you've got here so far is good.
Okay.
The relationship you're missing now is between the customer and the concert.
Right. And so, do we need a table for that?
So yeah. So if you wanted to create well, from a database designs kind of thing, I would actually create another table. I don't, if you're using the example that I showed you, it links the customer to the I don't even know how it does the customer to the concert, like they're linked together. But I would probably create a tickets table or something like that, or an attendance list or something like that, and have a customer ID paired with a concert ID.
Okay, I like
And that's that
attendance
relationship.
list. Yeah.
Or ticket kind of thing, because it could be
Okay, yeah,
this
ticket.
customer has a ticket to this concert. And if you want to put some, if additional information is available, like how much did the ticket cost, then your concert you could actually calculate the total ticket sales for a concert, and you could also calculate how much the customer has spent on tickets. But that's not part of the problem.
And so we would consider customer and ID and concert ID to be foreign keys here.
Correct.
Okay.
Because they're pointing to a primary key in another table.
And then I guess, do we want to just invent a ticket ID for the primary key, or would we use the pair as the primary key? Like the pair of customer and concert IDs.
Assuming that a customer could buy only one ticket to the concert, you could use the pair.
Okay, yeah, that's fair.
But if they can purchase multiple tickets, then obviously you either need a quantity field or or they'd have to have duplicate records.
So maybe this is good enough then for the sake of the problem.
You don't forget to draw your foreign key primary key lines.
Sorry, what?
Ticket and connect ticket to customer and concert with your little lines.
Yeah.
If you wanted to do
that. Wait, so one customer ID, I guess, has many tickets.
Yep.
And then
because it specifically says a customer attends 0 or more concerts.
One concert has many tickets. So I guess like that.
Probably something along those lines.
Okay. Because yeah, I forgot, with many to many relationships, you need to make that like intermediary table, right?
Correct. Then you can box all those things in.
Yeah, so now we know how big they are. I'll make boxes for them. But I think this is something like what you would want. Like your class might have some specific formatting things.
Visio does a lot of that for you. So you can create a new table object, and there's like GUIs in Visio to say, okay, this is the column, this is the data type it's going to be, and then you can create those relationships. It's pretty straightforward once you get into Visio to do that kind of stuff. As far as you can just use the rare drawing tool up there.
Oh yeah, there's a rectangle tool, but I much prefer my squiggly rectangles.
Sure.
They're much better.
Make sure you post this in your art channel.
Yeah. Oh, what am I drawing? I'm just spacing out with that one. You guys are amazing. Yeah. I guess shout out to Jed for saving me here. But
well, Visio does a lot of this stuff for you. Again, if you just go into Visio and create a database diagram or ER diagram or something like that, it'll create all the little boxes for you, and all you have to do is just type in the information you're given. But the idea is every box represents a thing. So you got a customer, you got a concert, you got a producer, you got a ticket. They're all things. Those things have properties to them. First name, last name, start date, dollar amount, something like that. And then the things are related to each other. And the primary key is what identifies that thing from all other copies of that thing. So every concert will have a unique ID, and that's how you can identify the concert. If you wanted to throw a ticket ID in there, you could throw a ticket ID in there. as a primary key, because right now that doesn't have a primary key. But that's really up to the professor or whatever as far as whether every table has to have a primary key.
Yeah, there's definitely a lot of like style choices here, but I think like fundamentally we have the most important things right.
Yeah. So, and that's he's already published that into the Discord as well for you.
Do you have to have the upgraded version of Visio for the boxes to create itself? Are you doing it manually? I don't know about
No,
that. Okay.
I don't know if Visio has a demo or a trial or anything like that. Did you get access to Visio as a student of this class? Did they give you access to that?
Yeah, hopefully if you're getting it through your school, they're giving you the full version, or if there even is one. So hey, Bombax.
Well, I used to use Visio because it used to be part of Microsoft, like the high-end version of Office, but then they've taken it out and made it a separate product that's not included in Microsoft Office anymore. So I've used some other tools and stuff, and there's some free like clones of Visio, but they don't actually produce a Visio diagram.
Okay.
Matter of fact, if you created, I actually have a large database that I use at work. And so I actually bring up Visio, I say reverse engineer this database, and it creates all the tables with all the attributes and the relationships and basically builds the diagram for me from the database.
Oh, nice.
So it's great.
Um, so yeah, I haven't used Visio myself in a very long time, but Destiny, if you have any further questions, I guess let us know. But I posted a screenshot of this in the Discord in the same channel where you asked the question in case you want to like refer back to it. But hopefully that gets you a good start there. I guess anything else to say about this, Judd?
You should make sure you don't change your name, your name on Twitch to GPT, because it should have gotten this from the chat.
Yeah. I've changed my name to AI generated software, i.e. Chat GPT. It's a great.
I think I don't know, does Chat GPT have a Twitch channel? That would be interesting.
I've seen AI generated streams before. Or like basically like
Draw.io.
Draw.io is very nice. And welcome to Bilo. No worries, Destiny. But all right. Thank you for the help, Jed. I'm super rusty on this.
I'm not trying to like no. I couldn't get my finger down to the sound effect.
Yeah.
So. But you caught them at the same time I wrote no, so.
Yeah, it just I was trying to remember like what direction you draw the. I think those are called like crow's feet or something.
Yeah,
little
it's basically if you think of it, this one thing goes to multiple records, so it's just it kind of makes sense when you look at it.
Yeah.
Then there's all these little weird circles and stuff you can do where it could be like it could be 0 to actually for the customer to ticket. Technically, I think you need to put a 0 before the crow feet because customers may not have any tickets.
Oh, yeah, there might be a different symbol for that or something
symbol
too.
that you can do.
Yeah.
Yeah, it's like like a little 0 before the or a circle right before the crow's feet.
Okay.
And then the same way for the concert may not have any tickets sold to it yet, but a concert has to have a producer. So, so that one you would not have a 0 on that side. Actually, I guess you could have a producer that hasn't produced any concerts, so I guess you could put a 0 on that one too.
Yeah, I remember there being notation for like optional and required columns. Like I think it was like maybe pluses and minuses that you could do.
Yeah.
And like what a data type. But yeah,
there are a couple different ways you can diagram it. It's just it's all stylistic choices.
Mm-hmm.
Cool.
All right.
Hey, talk good.
Well, thank you, Jed. Okay. So there's more private question about it later? Yes, sounds good. Like I said, I'm pretty rusty on this stuff, but Jed like does stuff like this for a living, and I can always Google stuff and refresh my memory if he's not around too. So, um, I can't promise that they know about databases, but since you are a new face in chat, I do like to let people know that if you ever do find yourself needing map help, then there's a whole niche of this on Twitch. It's not just me. Eats to Toy Pie in that list, who is also in chat here, does know some like coding things in general. So if you're running into issues, he may be able to help too. Yeah. Okay, let me catch up with chat because I've been seeing a lot of things while we were talking. So Bombax, yeah, we're doing some database things. Get into programming. I want to do some more programming on stream. I'm pretty bad at it. Dr. Ellie got some awesome concert tickets. Nora Jones, is that a joke or who are you seeing? Amsterdam is overrated, really? I think it'd be cool to see. Continue our series of coding challenges. Yeah, Zach. Fish. Oh, nice. I don't think I've ever like listened to them, but I've heard of them. Um, yeah, I feel like we just need to find a good source of like or maybe that could be something we do like once the series classes ended, but like I'm sure there's some interesting like book or website with programming questions out there that would be good for us to draw from. We have to like find it. Here's our how's my mechanics textbook been going? It hasn't been going. I uh I really want to keep on going with it, and I probably just need to stop doing as many problems from each chapter as I have been doing. I'm still maybe halfway through the chapter on energy. But I just need to start doing that like off stream if I want to actually make any progress at this point. That there's very little downtime on stream nowadays, which is great. Um, yeah, I think it's just like syntax error is really good at coming up with crazy problems. So I still have questioning where he gets these from. See out hello world. There you go. That's some good code. So what's up with this tangent thing? To the last line of defense, what's something I can do? I do it. So you Google it. So you can ask goddamn AI about it. Oh, Zach, that seems pretty clutch. Let's take a look. Okay, this is what I was gonna say, and then I walked it back, so I was wondering if I was gonna say something stupid. With that Gaussian something going to 2n being like 2 times triangular numbers, or not 2 times, but the triangular numbers to 2n. Oh my god. This is not at all obvious. You're right, Zach. What the hell? There you go. Yeah. Great find, Zach. Approach with the residue theorem? I have no clue, personally. Okay. I think we don't have any questions that are waiting. So if anyone has a question, please do let me know. But maybe we do have some downtime for the stream now. Maybe should we do some physics? Because we're doing analysis before. God, I have to clean up this file. Yeah, I don't know how you compare web browsers. I know that Brave is the like privacy focused one, which I love the at least that ideal. Um I don't know how to actually verify stuff like that for yourself. But I do love like having that privacy focus at least as a goal. Like so we ended up doing I think I got number 11 like number 11 is done. I think I got it like mostly right. I guess let's look either at number 12 or maybe we'll skip it if it doesn't seem interesting. Um Bungee jumping? Well, bungee jumping is interesting. Let's try this. Yeah, finally Fembox, some mechanics. Yeah, go ahead, Papadoria. All right, well, if you're cheering for mechanics, you're about to be disappointed, I think. But we might have a very difficult Papadoria problem. So that's always cool too. We'll see how long this one takes me, Papadoria, but this is always just like a filler. The point of the stream is always to take questions from chat. Sounds good, Yanis. Thanks for hanging out. Hope you get some good sleep. Um. Ooh. Well, let's take a look at this question. I see you posted it. Time to learn some LaTeX. Yeah, if you want an easy thing, like the Discord server can actually render LaTeX. So it's a really helpful bot. Like I love this bot. But you can do like what's a good like just like enclose your LaTeX in $signs, and there's a bot that'll render it. So if that's ever a helpful thing, like please feel free to just like use that too. Now, Discord isn't a very good like LaTeX editor because it doesn't like, you know, fill things in for you or check your brackets, but it is super convenient not to have to go through like Overleaf or something. Okay, let's read through this question and see what we're in for here. Prove that for all alpha, beta. Let me cut off so I'm clear what question we're on. For all alpha, beta, and R, there exists a kg such that kg is a proper subset of natural numbers with 0. In case of I is equal to the floor of beta. Oh god. Rose on a Wikipedia page? Oh, that's funny. Ugh. Reminds me of like seeing Stuki use Stack Exchange as a LaTeX editor. G sub I is equal, or it's less than the floor of beta. Where alpha, oh, what is this? I mean, if you're like if you want a real LaTeX editor, then overleaf.com it probably is. Just like Google Overleaf, and that's really like it's a free and it's free and it's popular. Any real number can be expressed as the sum of integer coefficient powers of any real beta. Coefficients are natural numbers including 0. It's a translation you got when you plugged it into Chat GPT. Essentially, prove with any real base, we can get any number. You can get any number from base negative pi or something like that. Yeah. Um, I feel like I just can't do this question though. I'm getting very confused. Like, I can kind of see what's happening here, where like, um, alpha, like you have to make alpha is like your any real number. Well, I mean, alpha and beta are both, but like, well, the thing we're choosing is k and g. It has to work for any beta. Like, beta is your base, it seems, and alpha is just any real number can be expressed in any real number base. Um, we have to prove that a k and g in base 0. uh, you know, that's a fair point, Jed. Maybe we can't allow beta equals 0. That does seem to break things. This is a translation as well, so base pi is okay though, apparently. 42 would be irrational in base pi, I think, but you can actually have like base pi is a real thing as far as I know. Why can't I draw beta? Most numbers of non-integer bases are irrational. I would believe that, yeah. I guess you could say most numbers are irrational in general, right? I'm probably I'm talking about something that I don't understand, but there are more irrational numbers than rational numbers, right? And that's why R is greater than Q. Probability of irrational number or real number is 1. Well, why can't you say probability of real is 1? Um, oh, that's a good question. Is R less than C? I have no clue. That's a terrible R, by the way. Oh, given. The probability of irrational given it's real is 1. Sorry, I was reading, I forgot that's a notation for conditional. I was thinking of, like, coding with the double vertical barping or... Yeah, that was just, like, a random... Like, not related to the problem above, but that was, like, a problem that Papadoria asked, like, separately. Um, and I have no clue. My gut says equal, but I don't really have a justification for that. Well, no. Do I? Maybe it's not equal. I don't know. But yeah, in cardinality, they're equal. Really? I was getting weirded out because the complex numbers are like uh, a vector in R2, but I that's where I was getting confused on like where how you really compare these things. C is isomorphic to R times R, and the cardinality of R times R is equal to R. Huh. Okay, so that's the formal way of what I was intuitively thinking. The isomorphism. Shouldn't C be intuitively bigger? I feel like C encapsulates all of our. Well, I mean, I'm thinking like C is basically just a pair of real numbers. Like R is bigger than Q in my mind because it's adding something that's entirely not contained in Q and not expressible in Q, at least easily. Uh, but C isn't really adding anything that new, I guess. I don't know. Like just because one contains the other doesn't mean they're not equal. They, or sorry, C encapsulates all of R if we say A plus BI, where A is a number and B is 0. I think the issue is you can go in both directions. So C does encapsulate all of R, but evidently R should encapsulate all of C in some way. There should be, if it's true that they're equal, as Zach is saying, then there should be some kind of mapping from R onto C, I guess. I don't know how you would make that. It's probably complicated, but but you could say that integers encapsulate natural numbers, but their cardinalities are still equal. And so I think that's the same thing that's happening with real and complex. Or like it's a similar like issue. N, Z, Q, and R like dots on a number line. Between Q and R is just more dots between each existing dot on the Q line. C doesn't add more points, but another axis fully of numbers. Yeah, I can't pretend to really know the answer to that question. I don't know what area of math this falls under exactly, but apparently the cardinality of R times R, or like R2, is the same as the cardinality of just R. So adding the extra axis doesn't do all that much. You consider it's just set theory? Okay. Shouldn't you be in Bedstorm? No, I'm just kidding. You save it as late as you want. You need to find bijective function between C and R. Yeah, so I assume that one exists. You are in bed? Okay, there you go. I bet someone on Stack Exchange has thought about that. Ooh. Is this Twiddles? That better not be Twiddles. This reminds me of space filling curves. I never heard of those. What the hell is happening here? Oh, hey, space filling curves. Piano curve. Wait, is that the same person as the chess dude? Isn't there a chess opening like the Joko piano? Maybe it's a different piano. I don't see chess anywhere on here. Chess. Nope. Okay, that's a different piano. Anyway, you really need to have a set of streams on fractals now? 0, 1 is the same cardinality as R. Oh, yeah, yeah. Converts 1 degree of freedom into 2. For how you... Oh, okay, from going from 1-dimensional to 2-dimensional? Does R equals C equals H equals O equals S? I never heard... I don't know what H, O, and S are as sets. A curve in 2 or 3 or higher dimensions can be thought of as the path of a continuously moving point. Quaternions, octonions, and sedenions. Oh. I know, you have to ask someone who's better at math than I am if those are all equal in cardinality. R equals C equals H equals O equals S. I don't know. When you add on more dimensions, I assume weird things can happen. Quaternions are useful in rotation for 3D rendering. Oh, I didn't know that. This is a cool one. Like a cool picture. HO as R to the 2N with some structure. You can also see H is just a group of 8 elements. For O and S, you don't know what properties are or use cases. What? This reminds me of those colorblind tests. Okay. Um, Wait, the dragon curve? This is only this isn't very dragon-like. This is like when they name a constellation like Leo, but it's just a stupid triangle. It's like it doesn't even look like a lion. I don't know if it's even a triangle, but it's like you have to really fill in the dots for yourself. Oh my god. It looks cool. I just don't see the dragonness, the dragonosity. That I've been watching a lot of Elden Ring lore videos, and this shape is reminding me of one of the runes that comes up a lot in Elden Ring. Oh yeah, I've heard of quaternions. It's like a complex number, but there's an I, J, and K, right? Yeah, or a J and a K. Also, popularity slash Piggy Master. I kind of completely forgot about the question you originally asked. I feel like I probably can't do it though. This is a cool little Wikipedia rabbit hole though. Wait, when the answer dawned on Hampson could not resist the urge to carve the formula for the quaternions into the stone of the Ruggum Bridge? Well, where's the actual carving? Did it fade away? Oh, the carving has since faded away. An annual pilgrimage since 1989 called the Hamilton Walk for scientists and mathematicians who walk from Dunsink Observatory to the Royal Canal Bridge in remembrance of Hamilton's discovery. The running of the nerds, as I like to call it. Hmm. Um. Yeah, I I get the idea of what it's trying to prove, I guess. I just have no idea how you even start this. Resurrected facilities try and it's not due for another 2 weeks. Okay. The running of the nerds. And Cytos, you did ask that question, or you did put that question in Discord for fun before, right? I don't have an excuse now. I probably should look at it. I feel like you just get it into exponential form though, and you get something that's good. Or polar form. So the question is just to simplify this. Oh, I assume that was a typo. It's probably just like supposed to be only one beta. But what happened to the second part of the statement? Basically, like the way it's constructed in the problem is that beta is your base. Um, a cubed, but a cubed. Don't you get like foiling that happens? Or like is like we can't just take the 1/3 power after. I mean, let's put into exponent or polar form, whatever. What? Wait, but why doesn't this? I trust that you're right, Storm, but like I need to see why I can't just get these in polar form and take the 1/3 power. Like I don't get what's wrong with that. Um. Oh, that's an annoying arctan, I guess. Oh wait, is that not even unit circle? The plus will be awful to add the exponential. Yeah, I guess I see that now. Okay. I trust you, Storm. I just I need to see certain things for myself because I'm just not as experienced with this stuff. Um, and so Papadoria is saying that a cubed would be 1+i√7 plus 1 - i√7 minus 3. Minus should be a plus. Oh, like that right there? Okay. Then the aim is to find a polynomial which has a as the root, then solve the polynomial. Oh, so I shouldn't have gone through trouble writing that entire thing out. I should have literally had one equal to A, one equal to B. Independent value of A and B. Oh, okay. Uh, well, from either step, try to write A cubed as a polynomial in A. Like, isn't it going to be X cubed, or I guess like as in like A cubed minus like some complex number equals 0? And like simplifying all of this? We search for a real polynomial. Okay. The polar was my first thought, but then it seemed weird, and there's apparently a more efficient way. Uh, that Storm and Papadori are saying. Oh, A plus B equals oh. Um, so okay, so we need to search for A's and B's somewhere in here and make those equal to A. Oh, uh, find the king mate? Thank you for the raid. Welcome in, everyone. Oh, Cytos. Did you recommend me? Um, thank you so much. I hope your stream was good. Um, yeah, everyone. I'm Don. I do actual like math help streams. I do some game streams too. Right now, we're looking at this problem is to simplify that complex number. But yeah, welcome and thank you so much for the raid. Let me catch up with chat. So welcome in Lastig, Wheat Spreak Bear, hey, Skull, hello, Ice, hey, 9 plus 10, 21, Countless Timpani, hello, Holocrafter, Hate, Pipod. Hopefully I got everyone. 5 plus 6, 21 still. But yeah, well, welcome in. I hope that your stream was good. For you to like tell me like what were you doing? I'd love to hear more. Cytos was up to something, I guess. Skull, thank you for the follow. Can we say I assume we can safely add those numbers, I hope. Just get two. Bit of competition Holocrafter was soundly last. Came second by 0.5 points. Oh. Was it in Super Mario Maker? Me and Cytos are enemies? You know, fair enough. Cytos is known to just drop in some really tough math questions and watch the suffering commence, so I can see that. Cytos is not to everyone. Ugh. Oh, it's all the guys. We're having a good time, so I'm glad to hear that. Hey, Henrik. I wonder if I. Okay, yes. Storm is. I assume I've gone astray here. 3 ABA. And AB cubed is -6. Uh, is it? What's the square root of Cyto's intelligence? A bazillion I? um. Either way, so, Cytos, if that was you mentioned me, thank you. I appreciate that, and thank you again to Find a King for reading. Um, it's 8. Um, 8 makes sense. Yeah. Oh, okay. So, oh, that's what you're saying. So then just AB is 2. Oh, is this how you got the polynomial the other day? I remember you like there's some other problem where you like as far as I know you pulled a polynomial out of your ass. And I was like, okay, I'll go with it, but I have no clue where this is from. Your math is 50-50. Yeah. You have a big ass. You have a lot of math equations stored in there. This is way too complicated. The hardest thing I know is like X and Y are unknown and you get 2 equations. Hey, that's something. 50% math, 50% meth. Yeah. How you get to do math today? Oh, do tell. Trig sucks. It can be super annoying. It's helpful though. A equals 2 looks like a solution here, right? A minus... No, it sure doesn't look like a solution. Um... You just get the original expression? Okay. Trig is the best area of math, Papadorius says. I don't enjoy it for Trig's sake, but I enjoy it because it can answer more interesting questions, I guess. 1% math class did not fail Trig. Okay, it sounds like you had a really crappy teacher. Using ranges for very long range shooting. Oh, nice. Bullet velocity and weight determine how much drop will have over certain yardages. Oh, cool. That's some applied math right there. Trigonometry. um. So Storm says then you can conclude, but then Saito says solving this just gives you the original expression. I don't know what to do with this thing. Besides just letting Wolfram Alpha take the wheel for me. But it seems like from what Saito said that might even get a helpful thing? Question mark? The thing I heard about Trig is that for the rest you can do basically the same thing every time. Why don't you have to figure out what to do for each individual case? Uh I guess so, yeah. And in some ways you can memorize your way through Trig. Like the unit circle, if you have that down, you've got most of Trig down. Also the trig identities, like sine squared plus cosine squared is 1. I know, there are definitely some ways in trig they can really like mess with you though. Finally use math, it's only been 10 years. Better than never. Wait, you did a trig class and didn't learn the unit circle? You were really let down then. Let me show what it looks like. Why would you have that as a light blue background? That's so hard to read. It's basically like a reference tool where if you need to calculate like sine of 30 degrees, you just know to take the y value of this point. So sine of 30 degrees is equal to 1/2. Sine, cosine stuff, and Pythagoras. Okay, that's still something then. But this is like, to me, the central, like, or like one of the big things that you get from trig, because sine, cosine, and tangent of these values come up all the time in later math. You like the original idea of converting to polar? Saito says. So what are the roots of this polynomial though? If we are going to switch gears, because I don't know where else to bring that. There's two irrational. That doesn't look complex to me. What? Why would you call that complex, Wolfram? They're all awful, but we're right. They're just all awful. Okay. I guess let's go to polar form. Put that off to the side. Wolfram Alpha shat in the bed of this polynomial? It sure did. Oh, this thing, yeah, like it's called a cubic equation. So usually in like in algebra class they really grill you on like lines with y equals mx plus b and parabolas that are like x squared. This is the next one up, which is x cubed. Um, and so they're a lot harder to deal with, but it's still the same thing fundamentally. You think you could solve that? Good luck. There is a way to solve it. It will take a ton of computations to do it by hand, though. Uh, oh yeah, Destiny, it's Jed. But if it's like x squared or just x, then yeah, it's not that hard to do by hand. Oh, the you use Vietta's storm. I see what you mean. Yeah. Yeah, it's not as simple to factor when it's a cubed, unfortunately. So it should equal 37.654. There you go, Tyler. That's the answer. Case closed. Gamma x times gamma of 1 minus x is pi of sine over pi. What the heck? I didn't know that, Papadoria. The final root would be the 2.6? Okay. But yeah, you can make some connections between a problem like this and um like regular polynomials that you've learned about, like x squared plus 2x plus 1 is a quadratic. And actually, the reason it's so hard to do by hand is that like a quadratic like this has the quadratic formula, like the minus b plus or minus root b squared minus 4ac over 2a. There is an equivalent for a cubic, so like x cubed plus x squared plus x plus 1, but it's like a monster giant formula, which is why I'm saying it's so hard. It does exist though. Okay, so yeah, so we could continue here using Vietas, but we would need, or you're saying it'd be like a terrible thing? Search up the gamma reflection formula. Oh, I feel like I've actually looked at that before, Papadoria, but it's been a while. I feel like I've actually done sort of a proof of that, but not quite. Like an easier version of the proof. Okay, so if we do go back to the polar idea. So like arctan of root 7, that is just a number, I guess. Arctan is odd, so I'll put the minus sign out front. Oh, that's true. Yeah, when you don't have the x squared term, the formula is a lot better. Let me change some things around. Without the x squared, it's called a depressed cubic. Yeah, I've heard of that. I think it is. A cubic with no x squared term is called a depressed cubic. So sad. I'm gonna keep these as root 8s. Actually, it's gonna be a little cleaner if we do that. Okay. Uh, so the I here means an imaginary number. So it's the square root of -1. And actually, related to the quadratics we were talking about, um, you sometimes get quadratics that if you try to apply the formula to them, you get the square root of a negative number. And that discovery is kind of what spurred the idea of, oh, let's call square root of -1i, and it unlocks this whole other world of math called complex variables. But like if you try to apply the quadratic formula to that one that I wrote right there, x squared plus x plus 1, x is equal to -1 plus or minus root 1 minus 4 over 2, -1 plus or minus, this 1 minus 4 is -3. My teacher said square root of negative numbers don't exist. Your teacher partially lied to you. It depends on the context, whether that exists or not. As it turns out, it doesn't have to, like, you don't have to say, uh-oh, this math is wrong because you got the square root of a negative number. And I really hate that they say things just aren't allowed. Like, I feel like they're just lying to you. I would rather them have said, this thing is technically okay, but we're not going to go into it. But basically, if you end up with something like the square root of a negative number, you would say that root -3 is the same thing as the square root of -1 times the square root of 3. And we have a special letter for the square root of -1 that's I. It's called the imaginary number. Because it's not real. It's not a real number. That's where it comes from. If you allow the square root of -1 to exist in some way, you get you're stepping through the doorway into a whole new area of math. So that's why they probably wanted to avoid it. But yeah, it is allowed. Depending on what you're doing. And so a number that uses a number that uses the imaginary number, like say 2 plus 3i, is called a complex number. Kowalski analysis. And so here we have a complex number that's being cube-rooted plus another complex number that's also being cube-rooted, and we have to simplify that. And this is a hard problem, but that's what this problem is based on. Also, do we have to match? This looks a little bit like the definition of sine or cosine, right? Is that the idea? I forget which one. But like, wouldn't that make this problem a lot easier? This is cosine? Okay, yeah, and it's twice of that. Ugh. Yeah, and we use a right triangle to simplify that. So, one cool thing that complex variables lets you do that's related to trig is you can learn that cosine of x is equal to e, which you might not have learned about, but I'll talk about that in a second, to the ix plus e to the minus ix over 2. So cosine can also be expressed with imaginary numbers that don't use trig at all. And e is just a number. It's called Euler's number. And Euler is spelled like that. And it's a number just like pi. It's irrational. So pi is 3.141592 something. And e is 2.71, I think 828 something. And so, in the same way that pi comes up a lot with circles, e comes up a lot with exponentials. So this is an irrational number to an imaginary power, and that's just, it's a thing that you're allowed to do for whatever reason. And noticing that the thing we have right here is pretty similar. Wait, it's Kosh? No, Kosh has no eyes. We're fine. The thing I might have been looking at on the screen before may have been Kosh. I don't know what I was looking at before on the screen, but Kosh is there's no eyes in Kosh. There is no eye in Kosh. That's like just e to the x plus e to the minus x over 2, I think. Oh, cosine of x is Kosh of ix. Okay, sure. But yeah. Thank you for like paying attention and being willing to speak up though. Mariel cutting? But in this case we're okay. If you do think you see a mistake though, please do like speak up. I appreciate it. Okay, so let's factor the 8 to the 1 6 out. And then what remains is 2 times cosine. Oh, we have a third arctan though. That's annoying. Do we need a triple angle or something? When there's a 1/3 there, things get weird, don't they? No, this goes the wrong direction, right? This. Oh no, no! Stop! What? Okay, I didn't mean to click on that. Stop. Yeah, if I applied this formula, we'd be dividing our angle by 3, not multiplying by 3. Is there a 1/3 angle identity? Can I say like inverse? That's probably not the right term to use. No, it's gonna think of like inverse trig. How do you simplify it when there's the 1/3 involved? Just thinking about it. You can leave 1/3 inside the trig functions. I don't know what that means. Is there what you have inside the cosine is fine? I don't know how to simplify it though. Like, if I had a cosine of just arctan, I know that you can draw a right triangle and take the cosine of it. But if there's a 1/3, does this still work? Or are you saying this is the answer and we don't have to simplify it? I don't think you can eliminate the 1/3. Yeah, I'm curious if there is a geometric, or like if there is some kind of argument to accomplish that. But if that's an acceptable form to leave the answer in, I guess we did it. I just assumed that we would have to go further. 8 to the 1/6 isn't simplified though. Oh, um, I guess it's root 2. Is that it? Am I being dumb? No, that's okay. Then I'll put the 2 in front. Trig of inverse trig with coefficient. That's the answer? Okay. I want to find, like, just like sine of a third arc cosine x. Just anything with a third in it. Well, when there's a 2, you can do a half angle, can't you? All right, it doesn't seem like someone has asked this question. I said, oh, is this it? Okay, this is getting at the idea. If that's the answer, like, great. It's just, I am curious though if this is possible to simplify. Yeah, I agree, Storm. I don't know. Fair enough though. Yeah, I mean, it's still just it still is just a number. There's nothing wrong with it. I just don't like the way it looks, I guess. I wonder what Wolfram Alpha says about this. Gets the same thing. Okay. There we go. We can do a power series. Much more satisfying, right? All right. Fair enough, though. I think I need to take a little bathroom break here. And when I come back, we'll figure it out. This problem for future me. Okay. All right. Go to sleep, Storm. Sleep well. Thanks for your help today. I don't know. So like that did like that discussion with like people being told that you're not allowed to take the square root of a negative number, like did anyone else feel lied to when you learned that you can't take the square root of a negative number? Or that like sine and cosine aren't even real functions, like you can express them as e. Ooh. I don't know, for me there's like I kind of felt like a betrayal. Like I don't know. I think we're gonna go do physics. Oh wait, I'm not showing my journal plus plus, am I? At least do like this one problem at least. I don't know if we're gonna go for a ton longer, but I need to get on the physics more. Halfway through chapter 6. Oh, nice. At the same time, I've been kind of like, if I am gonna go to grad school, I feel like I should study some linear algebra and brush up on that. Like, I'm wondering if I should just do something with linear algebra and focus my efforts on that more. But I don't know. I haven't really like made up my mind on that. That's the plan, Fenbox. I haven't exactly worked out how that's going to look like. It depends where I get in, but ideally, yes. Starting in fall this year, I'll be in grad school. And like being rusty on linear algebra and knowing almost no complex analysis feels like a big gap in my knowledge. Real analysis, I feel like I've at least gotten a good start with Zach's classes. Uh, thank you, Fenbox. So far, it's not been good news, but I have a safety school, and there's still some hope for schools that I haven't heard back from yet. So we'll see. But I could hear back anytime between like now and like April, so there's still a potential wait. This is interesting. So the lowest point the jumper reaches is a distance 2L below the platform. Wait, that is grad school. Oh yeah, it does work differently in different countries, doesn't it? So at least in America, um, the undergrad is a 4-year degree, or potentially a 2-year degree, but I think normal people say their undergrad is a 4-year degree, so where you get a bachelor's. And the part where it gets weird for us is from that bachelor's, you can either do a master's, which is 2 years, or you can go straight to the next level, PhD, which is basically 5 years, but the first 2 years are you earning a master's. And so I've applied to both because often if you apply for a PhD and they don't accept you, they'll still consider you for a master's. The advantage of going straight for a PhD is that PhDs are not only are they free, but they pay you, whereas for a master's you have to pay tuition, and it can get very expensive very quickly. You can skip the master's, yeah, you can, and I think that's not a thing in Europe. Like you have to do the master's first, as far as I've heard, but I'm sure it varies by country. And so if you do go straight from a bachelor's into a PhD program, normally at the end of your first 2 years, you can like do a test or a presentation or some type of extra requirement to actually be awarded a master's as well. And if you wanted to, you could then drop out and have a master's degree that you got paid to do rather than paying tuition. Yeah. I think at one point I looked into what it would be like to apply to a. It was years ago, but I looked into what it would take to apply to a PhD in Europe, and that seemed like a common theme. Doctor is 5 years, so 7 years with a master's. Really? I thought it was like 3 years for a doctorate over there. And I think here it would be 3 years too if you already have the master's separately. It's a crazy amount of time. Yeah, fair enough. Do you happen to know if you have to like do you have to pay tuition for a master's, or is it free? University is free here, like $700 a year for the energy cost or something. Oh, okay, so even for like higher levels. Okay, that's really nice. I wish we had that here. So the lowest point, like I guess we would consider our 0 point to be 2L for the sake of getting potential energy, right? Oh no. Or do we want to set our origin at L? I think that they should both work. Maybe we'll do it at L though, because I feel like they did the previous problem kind of in that spirit. Education's pretty cool. Yeah. For huge recommendation from me, yeah. The Spectre Certification Corporation can recommend it. Uh, Yeah, like education, it should just be free. It's obviously not free to give, so someone has to pay at some point, but probably not a student who can't get a well-paying job yet. But could if they got a degree. Why am I redrawing this? Why not just take the figure itself and make it my own? No, I'm gonna make 0 the bottom. I don't like this. I'm gonna have to remember though that the extension only happens between L and 2L. We have to find the spring constant. I assume we need to get the energy to find the spring constant. So at the start, we have 2m. Why am I saying mg2l, but potential energy? And then at the end, we have 1/2 k L squared. Because the chord has length L naturally, and it stretches to 2L at the lowest point. And at that point, we have 0 gravitational potential energy. Anders? It's been a minute. I hope you've been well. Did me saying linear algebra before awaken you? Hey. Oopsie. Let's get the timer up. I was just thinking that I hadn't seen you around in a little bit. The Polygon song? Oh, and like Pen Center's stream, his like intro. All right, inspection. Ah. This is already a bad solve. Oh, terrible. Terrible. Ah, could have been way better. The cube kept getting stuck like halfway though, and slowing me down. And then I made a few mistakes, but oh well. Could have been worse. February is the month of work hell for you? Oh, that sucks. Are there like exams happening then? Entrance courses. Oh, okay. Yeah. So imagine they're very big classes and probably take a lot of work to maintain. But hey, at least February is almost over then. I hope you're in the home stretch. We're gonna have 4 simultaneously? Jeez, that sounds like a lot. Acceleration at the lowest point. I guess we want to use F equals ma? We have gravity going down and spring force going up. K we just solved for. Times stretch L. Three G? We're getting 3 Gs of acceleration. Or I still use a force, would you call it? I don't know. Hill position specified disable platform's jumper speed maximum. What is the speed? Um, it should be right at the midpoint, right? Where spring potential is 0? Or is it not that because of the gravitational potential energy? Acceleration is the derivative of velocity. In time. Um, do we do this? Set it equal to 0 and solve for x? L over 4. I don't know about that. Maybe I do know about that. Maybe that is okay. Because on the way down, we have acceleration g. On the way back up, I guess I just showed we have acceleration 3g. It is rapidly falling off, though. No, wait. I don't think this math is right. Yes, it is. I don't know. Is it? Yeah, I'm trying to picture what stage is my jumper implicitly at if these are the forces acting on them. Uh, because that would be L4 on the way down, and he's definitely still speeding up there on the way down. Um, Anders, geometry slash cal problem that someone posted a while ago. Figuring out the min and max of L equals the quotient of some distances. Sort of? Just the other day, we were talking about L representing a rotated line. I don't think that was it, though. Hey, Pradyumna. You saw it in a Discord server? P and Q fixed point. R is a point that moves along a plane. Yes! Yeah. Um, this one? It's in math discussion posted by Delta on February 8th. I'm pretty sure we did. I think Fembox found a solution. Oh, here's what I did apparently. Oh yeah. Oh yeah, you found that. Or that was a really crafty way of doing it. I think I found a solution, but it was pretty cumbersome. We're given the answer was 19, and I do see I ended up with 19. It seems like we solved it, but if you have something to say about it, I'm sure like I'd be interested to hear it, and the person who listed probably be interested to hear it too. Um, did someone post something new in the Discord as I was doing that? Oh, it looks like it. There's a couple of new things. Oh, it's the same thing posted twice. Okay. Let's take a look at this. This might be enough room here. Is this gonna use some crazy trig identity? I'll try it by hand first, but I tend to just plug into the to make sure it's not something crazy. Is this from you, Pradyumna? Cotangent is cosine over sine. Just want to see how this looks and see if anything jumps out. Is there Pythagorean identity in these? If sine squared plus cosine squared is 1, then divide everything through by cosine, and you get tan squared plus 1 is secant squared. Dividing through by sine, and you get 1 plus cotan squared is cosecant squared. So if I factor out a cosine squared from the top, the 1 over sine squared becomes cosecant squared. Yeah, that's gonna match something, I think. And from the bottom, I factor out a sine squared. So this one right here, we have 1 minus secant squared. Tangent squared is negative 1 minus secant squared. Can I say that? So it should be secant squared minus 1. Yeah, okay. And same thing down here. We can say cotangent squared is negative 1 minus cosecant squared. And we can bring the negatives to the other side. And then the cosine squared over sine squared is cotangent squared. Times negative... Oops, sorry, I should put the arguments in here. I'm being lazy here. I'm not putting alphas. But that is poor form. And so cotangent is just 1 over tangent. That really doesn't cancel, does it? Because they're being divided. I guess you could bring this tangent to the top if you call it cotangent. And so you could combine all these into just a cotangent to the 6 of alpha. That's allegedly simpler. So you got 2 Fembucks. Let's look at Wolfram Alpha and see if there's any other forms that it finds, but that's probably an answer right there. Hey Bob, cotangent squared alpha s minus t? What? I don't see anything simpler. So yeah, Prayona, if that is you, I hope this helps. Let me know if you have any questions about that. It's cosine minus cotangent. Oh, you factor out the co? Oh my god. Bruh. Don't question my... Yeah, my bad. Okay, so I think the answer, what my math says here, is that, oh, maybe it could be right. on the way down, I hit my maximum speed at L/4 down there. Does that seem reasonable? Because we need a lot of distance to let gravity accelerate us down, but the chord is starting to oppose that the closer to the bottom we get. So maybe L/4 is reasonable. Cosine squared of x minus cotangent squared of x is equal to O of x of t, or s squared minus t squared. Oh my god. The unhinged math. Where is x measured from? Ooh. Ah. Fembox, you sneaky devil. You're right. I didn't think about that. X is measured as distance below L here. So it's not a quarter of the way from the bottom, it's a quarter of the way from the halfway point. So it would be in distance below the platform, 5L/4 is the actual answer. And we need to get the speed as well. Because it's the entire L length plus a quarter of L. That makes more sense. I felt like that's a little too far down. Like the spring or the cord has been acting for a while. Think of X as the spring stretch length. Yeah, I need to think of it like that, and I always forget to, Territar. What is the speed? I guess we can figure that out with kinetic energy. Two mgl plus mgx. Did it say to ignore gravitational potential energy after compression? I don't think it says to ignore the gravitational potential. Yeah, maybe it was a different problem. Papadori with another random question. Is there a non-piecewise function that is non-differentiable at all points? So I can name a non-piecewise function that isn't differentiable at one point, which is root x squared. I don't know if you could use that to build one that's differentiable at no points. Or it's, yeah, that it's... words. A non-piecewise function that is non-differentiable at all points. I can't think of one either. Fuzzy cosine? Weierstrass function? Let's Google. Is fuzzy cosine a real thing? Continuous everywhere, but differentiable nowhere. It's an example of a fractal. Today is the fractal day. Oh, this is also fuzzy cosine? Oh, as a Fourier series. Oh, hey, so yeah, if you allow an infinite series of things, sure. That's not piecewise. It is infinite, but it's not piecewise. I guess that's your formula right there, Papadoria. Oh, wait. Maybe? Yeah. It is differentiable almost nowhere. Okay. It's differentiable on a null set of points? Oh my god. Another Sierpinski triangle? Lebesgue measurable set of real numbers that has measure 0. I think that'd be like the rational numbers. Yeah. Dude, I swear, for the last, like, even, like, few months, things, like, happen in waves. The same thing comes up on the same day, like, over and over again. I choose to believe that it's a conspiracy. Uh, Today, Big Math is trying to get me interested in fractals. I guess. Or everyone interested in fractals. Harnell? What? What is Har? That's such a weird. That has to be a name, right? Alfred Har. It's a Hungarian name. Okay. Well, I guess that answers your question, Papadoria. If you allow an infinite series, then the answer is yes. Okay, so what? I think we found the position where this happens, and so theoretically we can find the speed. I'm gonna flick the pen. The speed. So we know at the start we have 2 mgl of gravitational potential energy. And then at the point in time, or the point in space, rather, we're interested in is, 5L over 4 measured from the top. In my coordinate system is 3L over 4 measured from the bottom. So that's our gravitational potential energy, 3/4 mgl. We have positive spring potential energy because it's being stretched by a quarter. And we have kinetic energy that we want to figure out. That's an annoying expression, isn't it? We can isolate V, though. It's a lovely expression and not annoying in every way. You're right. I'm being very rude towards this expression. I need to take a good hard look at myself and why I would think like this. 1/32 KL squared. It's 1/2 MV squared. All right, multiply through by 2, divide out the M. This is our velocity. Can we check if this is a positive number? I guess it just depends. Oh, you're right. We know what K is. Ugh, I forgot. Let's back up. Let's back up to I guess we'll only back up to this step. 4 mg over L. I want to back up further. I have plenty of room. Let's just space my work out. There's no reason not to. I'm not wasting paper. I'm wasting negligibly more RAM, if anything. It does sound similar. This is Tokyo by Vice. I don't I pronounce it, but what is that? Well, the entire thing. 1/8 in front. MGL. Yep, I like that. This will be cleaner now. Let's multiply third by 2 and divide out the m's before I deal with fraction math. Is gravity times length? That is the square of velocity, right? Yeah. 5/2 minus 1/4. 9/4? Yeah, okay. Oh, wow, that's a perfect square. It's like it was meant to be. All right, let's check it. Number 12. Four mg over L. Got part A, right? Three mg. Hell yeah. B is right. You do think of it as a derivative. A instead of equal to 0. L/4. Okay, good. Thank God you guys caught me with remembering that this is I guess the extension distance, and I need to get the distance below the platform. Okay, so the book skips straight to change in potential energy, which is fine. 3/2 root GL. Bam. Boom, 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 boom. What does the rest of the chapter look like? "13. Following platforms have a common theme." Oh god. This seems like something Damie would. This is like a baby version of the problems that Damie does. You said that too. Sing boom 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 at work. Yeah, it's so catchy. There's a lot more energy problems. 5.24 was brutal. Oh no. That does look annoying. The question I'm asking myself right now is, at what point do I call chapter 5 good? Give me a few days to think about how to work it out. I mean, I can kind of see like as theta, or as that angle, um it depends how you're measuring it, but increase or decrease. The further it falls over, the less the normal force is, right? And that's the idea behind why it'll eventually slip and become, I guess, kinetic friction. Wait, I remember that being really backwards. Is friction, or is slipping, is slipping static friction? It has to be kinetic, right? Is that probably in the forces chapter? If there is slipping, then it's kinetic. Okay. Table of contents envy. Yeah. It was annoying to go through and like manually make all these, but it's really helpful. Um, what time is it? I kind of wanted to do one more. I'm still not sure at what point I want to cut off chapter 5 and just skip to chapter 6. I'm definitely not going to do all these problems. But at some point I should just try to get through it a bit quicker, I think. Okay, block with mass m is located at position x equals 0 on a horizontal table. Spring with constant k and relaxed length 0 is connected to it. The other end anchored at position x equals L. Coefficient of friction, both static and kinetic, in the blocking table depends on position according to mu equals ax, where a is a constant. Assume the block is small enough so that it touches the table at essentially only one value of x. Oh, okay, yeah. Right, because if friction depends on x, then in theory, like this end of the block would experience more friction than this end of the block, but we get to neglect that. The relaxed length of the spring is 0. Okay. Where does it come to rest for the first time? It doesn't come to rest at the very end because friction is involved, I assume? Like this is going to be a damped oscillation? So we can use energy. Right? Well, at the very start, we have 1/2 k. We are stretched a length L. And then at whatever point we come to rest, I guess we'll call it X. Or like it's okay to use X here. Oh, hey. Oh, no, okay, this isn't the song. It's not a bad song, though. K. This is going to be L minus X is the remaining stretch. Plus, now how do I think about friction with energy? I guess we integrate it? Oh, it's gonna have, no, there's no kinetic energies at rest. I think the we just think about as work done by friction. Which is the integral from 0 to x AX times the normal force, which is mg? I think that's okay. And we're solving this for x. It's good to you? Okay. It's a good sign. So the half KL squareds drop out. What am I writing? That times that. And factor an x out. X equals 0 is trivial, you might say. But it's a good sign that we got it from the problem, right? I think, I hope. From that piece, KL equals a half K plus a half AMG. Two KL over K plus AMG. What units is this? Newtons on top divided by Newton per meter plus Newton? Isn't A dimensionless? No, A is inverse meters. It has to be. So the units check out, yeah. I guess that's our answer for the first part of the question. What does it come to rest for the first time? What is the condition for A, on A, for which the stopping point is to the right of x equals L, the anchor point? Assume the blocking somehow passed through the anchor. A controls friction. A is probably going to be very small, right? I mean, well, we can just set up an inequality and solve it. Two KL over K plus AMG. Oh, that'd be funny if this G was somehow a Y and like if we're spelling out Amy. You want it to be greater than L? Yeah. So we're solving this for A. A. This is probably a positive number, so let's multiply each side by it. Wait, does K come before L? IJKL. Should I order a pizza or should I go to the grocery store? Ooh. I've been craving pizza recently, personally. What kind of pizza are we talking here? And I guess what would you get from the grocery store? Mushroom? Like only mushrooms? You don't know yet? Fair enough. Mushroom and hot pepper. Okay, I can get behind that. I've been craving like that exact combo because my favorite pizza is bacon garlic jalapeno. But the last few years I kind of started being a mostly vegetarian, and I've been wondering how I can like substitute it. And I'm like, oh, I wonder if mushrooms would taste good instead of bacon. So I've been craving that specifically, like just to, like try it. Do these units check out? Yeah, they're inverse meters. So A is smaller than K over mg. Seems reasonable. Garlic in the oh, is it like pre-minced garlic? I just love garlic in general. I just don't like that I can still taste it like the next morning on my tongue if it's not like cooked through. But it tastes like so good in the moment that I don't really care. Same with onions. Like both of those take like 2 rounds of me brushing my teeth to like really get rid of the aftertaste. Red onion in the fridge too. Jeez. You're reminding me that I'm hungry right now. And I mean, sorry, I'm facing out just thinking about food right now. I I don't know. Like what you should do. If some point is to the right of the anchor, what is the condition on A for which the block starts moving leftward after it instantaneously comes to rest? If the stopping point is to the right of the anchor, what is the condition on A for which the block starts moving leftward after it instantaneously comes to rest? Oh, so it doesn't just stop there. I was imagining it wouldn't stop there, but yeah, I guess the friction might be enough that it does stop. So if A is smaller than K over mg, there's presumably some minimum also. No. maybe an even smaller maximum. Uh, and I think we can think about that with forces because we know something, right? We know this X. Oh wait, you know what? As a little exercise, what happens if A equals K over mg? You just get X equals L? I guess that makes sense. Okay, yeah, fair enough. Um, so we're looking for the spring force being greater than the friction force in part B, I think. The spring force is K times the displacement we just found. Wait, minus L. Yeah, for how this is defined, we do minus L. For the stretch distance to the right, we want the spring force to be greater than the friction force. The friction force is A. X is the same X as before. Times normal force, mg. And we need to solve this for A. Okay. This is annoying to solve for A. Look how many... we have 5 constants. Well, 6 if you include 2. All in that numerator. All right, let's get rid of these denominators. Um, A over 3 mg is greater than A. Oh, hey. Well, wait. Yeah. No. Yes. This is a smaller maximum compared to the answer we got before. It's stricter. The friction, yeah. Okay. If the friction is relatively high, it stops before the 0 point. If the friction is in a certain range, it'll go past the 0 point and stop. And if the friction is really small, it'll go past the 0 point and come back. In the cutoff case where it barely starts moving again, where is this first stopping point? So we take A equal to K over 3mg and find X. No. Using this formula for X, we plug in the value for A we just got. The K's can cancel. The mg's can cancel. Four thirds is equal to 3L over 2. Seems reasonable. Because that's like over here, 3L over 2. So we're not going past our starting point or anything. Yeah, this feels good. Let's see if I'm right. What number is this? Number 14. Okay, I got the work done by friction. Good. X is 2L over 1. Oh, they canceled the K. I feel like that looks a lot uglier. But same answer as I got. A less than K over mg. Same as I got. K over 3mg. Oh, wait. Did I? Yes, no, I did account for the X minus L. I thought I forgot that again, but no, I did do that. Three L over 2. Boom, 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 boom. All right, and that'd be it for me for the day, folks. We got two physics problems right in a row, though. That is a rare accomplishment. Um, yeah, let's take that victory and run. Oh, the white lights. Oh my god, it is late for Spectre. Why do they look so blue right now? They look the same color in real life, but in the game they look kind of blue. I don't know why. Um, Either way though. Uh, it's gonna be the end of the YouTube stream. So nice here on YouTube. Thanks for being here. We'll be back on Tuesday. So goodbye, YouTube.